Okay. Now, how do you do that? How will you sort data if you will be using, as in, this one will be a problem of Cheska because she has a lot of she has a lot of programs. Cheska will do ebook, site, social work, Bliss. So she'll have 4. And then Jeanette, I think, will have sections, and then Jerlyn will have HMTM. Now, if you want to count them manually, I don't. That's just fine. Go ahead, count them. But actually, it's easier if you use the count if function. Do you know how to use the count if function? Oh, you know, I will not teach you. So it was, let's put in count if, the range that we are going to use. Highlight the range. Please follow what I'm doing. Highlight the range. Be careful. Highlight them all. And then, comma. And then, what are we looking for? Claims. And then, same. 5. Please do the other parts. CBAA. Actually, I can just drag it down. But I will do something. Please work on your papers. AO papers. And then we'll see if we have the same answer. Same? Is it the same as the manual?
Yes po, ma'am.
Good. So that's how you use that. No, that's the count if function. Now, let's try this time to identify the number of students in public and private schools. Please do it. Count if public, private. Same. 1821. Why is it 39? Something's wrong. Wait. Something's wrong. It's not 29. 41. 42. Hmm. Answer.
1821. 22.
1822. Same for everyone? Okay. So that is your descriptive statistics, no? Next now, try to go to the Word file. Can you see my Word file? So this is how it should be presented, no? Uh, so in your Word file, you have to put in uh, your colleges in alphabetical order. Better if it's like that. Put the number of frequency and then put the percentage. Now, how do we compute the percentage, please? How do we get this percent?
Ma'am, I think po it should divide the department
Mm-hmm.
to the total population and then times 100 po.
Very good. So that's it, no? You can work on that. You divide the total number per college, divided by the total number population, then multiplied by 100, and then you'll get the percentage. That's very good. So this, for your interpretation of data, you just have to write down what it is that you see. So the table shows, or the table showcases the distribution of respondents. Just put it there. Again, no, as a general rule, if your numbers are not greater than 9, they should all be spelled out. But if they are but if they are 10 and above, they should be written as figures, right? Yeah. So these are all that you need to put. So it's not that difficult, right? It's so easy, easy peasy. Now we'll go to the next. So this is for the type of school. So this time the same thing. You'll just make use of frequency and then percentage. So 18 and 22, and then the interpretation. That's just it. You just have to give the descriptive statistics of that. Now, let's try again. Ayan. So we're done with question number 1. Now, let's try to do question number 2. How may the student's general weighted average be described? So let's see. GWA. How do we do this? How do we get the GWA of the students? What function are we going to use in Excel? Thank you everyone for answering. We can use the average function, equals average, then just highlight them all. That's it. 89.15. Do we have the same answer?
Yes.
Ayan, very good. So we have the same answer, no? 89.15. What now is 89.15 if we are going to describe it? Okay. If we're going to describe it, 89.15, you remember the DepEd grading system? 90 and above is outstanding. 85 to 89 is very satisfactory. So the DepEd order number 8 series of 2015. You should be very familiar with that because that is what we use for our grading system. So this is that one. Yeah. So you'll have this is how the table looks like. You'll have your N. What is N again? What does N stand for?
Population.
Very good. That's the total population. 40. And then you have the mean, which is 89.15. Now, there is an SD here, standard deviation. And it's not here. Where do we get that? We can get that by using the standard deviation function. So STDev, sorry. Then same thing, highlight. That's the answer. Now, what does standard deviation stand for? What is it used for? You remember what standard deviation is? Mom is just there. Mom, let's not try to analyze. What is it for? No, the standard deviation shows you the distribution of the answers, whether they're far away from each other or they're closer to each other. So the smaller the number, the closer they are to each other. Yeah. No. So meaning if the standard deviation is so far away from each other, therefore there is somebody who scores maybe 70 and then there's somebody who scores 99. So they're very far from each other. Unlike in our case, it's 5.01. Therefore, they're closely related to each other. So the standard deviation is just fine. It's properly distributed. Okay? So we have already answered number 2. Cheska, will you do number 3, standard motivation? And then Jerlyn, self-efficacy. And then college achievement test. Hannah, are you there?
Yes, ma'am.
Okay, please do that. Level of motivation is Cheska, self-efficacy is Jerlyn, and then Hannah, college achievement test. And I still have one more. No, mock test results. Jeanette, please do mock test results. Here. But actually everybody should do the activity, same thing. No? So let's see if you have the same answer. Is it cold? It's not that cold. Please include standard deviation. Huh? So you are very serious in a math class. Now I see your faces.
Ma'am,
Yes.
as for the level of motivation, the average is 3.35 and the STDEV or standard deviation is 0.50.
The same with everyone? Okay, same. Cheska, let's try to look at the interpretation. So this will be the table of interpretation. If that's the case, what is the level of motivation of your students? For the verbal interpretation. Where are they here? 3 point what?
3.35.
3.35. Now, what do you say about the level of motivation of your students?
Very high po, ma'am.
Very, very high.
So very high level of motivation. Thank you for that. The others?
Ma'am, pwede ba siya sa phone? Wala po akong laptop.
Phone? I'm not sure if you can use your phone. You can use your phone, but it's difficult. Maybe Jedi or Jed, please help Hannah. What's your assignment, Hannah? What part? Achievement test.
The achievement test.
Please do that, Jedi or Jed.
Ma'am, the achievement test results is 86.05 and the standard deviation po is 5.55.
Is it the same with everybody?
Yes, ma'am.
Okay. That's my way of checking. No. Another way of checking is if you go to the Word file, the answers are there actually. So it's not that difficult to check. Who else? Jeanette and Jerlene. Self-efficacy and mock test results.
Ma'am, for the mock test result po, ang average po is 85 and then yung standard deviation po is 5.
85 as in full 85.0.
Yes. Mock
Mhm.
test po, ma'am. Yes po.
And then the STDev.
Sakto pong 5.
Okay, thank you. And Jerlene.
Sa level of self-efficacy po, yung average po is 3.36. And yung standard deviation po is 0.57.
So where are we here? On the interpretation?
Very high po.
Yan. So the same, no? Very high self-efficacy and very high level of motivation. Ayan. Yay. Actually, it's separated here already. That's just fine. On the second page. But we worked on the first page. That's just fine. Okay, so let's continue. Now, for the inferential statistics, there are these are the tests that we are going to do. We'll do 3 today. Yung independent samples t-test, paired samples t-test, and then one-way ANOVA. The correlation and the regression, we'll do it live because I want you to compute live. I want you to compute it manually. No. But we will not compute the independent and the paired samples in ANOVA live because I did that already and it took me half a day to compute. I am not that bad. Okay. So we will start first, of course, before we go there, we have to understand that in these types of things, in inferential statistics, we are testing your hypothesis. Remember that you have, especially the 3 of you there, you have your hypothesis. Cheska, can you recite? Of course you can. Cheska, will you recite your hypothesis or hypothesis? Do you still remember it? Of course you should. Ma'am, I need my paper.
Ma'am, I'll read it na po. Hindi ko po ma-memorize.
No problem, go ahead.
The hypothesis of the study of the use of online grammar checkers and English writing proficiency. First, there is no significant difference in the frequency of use of online grammar checkers between male and female students. Second one, there is no significant difference in the writing proficiency between male and female students. Third, there is no significant difference in the perceived and actual writing proficiency of the students. And lastly, there is no significant relationship between online grammar checkers and English writing proficiency.
Thank you, Cheska, for that. So she has 4 null hypotheses, and she'll be testing all those hypotheses once she gets the data that she needs. And she will have a lot of data. How many students, Cheska, again? Will you have? How many? 80 plus? Ma'am, I forgot, Ma'am.
101 po.
101. So she'll have 101 data, and all these data will be encoded like this. No. I'm telling you now, the challenging part is really getting the data and encoding the data and checking the data, especially for Cheska. Jerlene, your hypothesis, please.
My hypothesis there is no significant relationship between students' use of English subtitles and English reading attitudes. There is no significant difference between the male and female students in using English subtitles. And third po, there is no significant difference between the male and female reading attitudes.
Thank you. That's right. No. So we'll be working on the 2 today, the significant differences. So she'll have 3 hypotheses, null hypotheses. And Jeanette?
First po, there's no significant difference in the level of academic stress between males and females. Second, there's no significant difference in the level of academic performance between males and females.
Mhm.
And third po, there's no significant relationship between academic stress and academic performance.
Yeah, so again, no, she has 3. Wow, you have a lot of hypotheses that you want to check. Now, but we'll be able to do that. And how will we be able to do that? Once you get your data, we will use MS Excel to, or we can use SPSS. Actually, SPSS is easier. I have it. Maybe we can just run it here so that it's easier for you. But of course, I want to make your life difficult. So let's use Excel first. Now, for the null and alternative hypothesis, so the null hypothesis, no, as you mentioned, this is the statement being tested and it's usually written in the negative statement. That is why there is no significant difference and there is no significant relationship. And then the opposite of that is the alternative hypothesis, which is positively phrased, meaning there is a significant relationship between on the use of online grammar checkers in gender or sex, something like that. So it's positively phrased. The most important value that you have to remember is 0.05. Very, 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 very important. 0.05. If your value is lower than 0.05, then we accept or reject. We reject the hypothesis. No. But if it's more than 0.05, we accept the hypothesis. Again, for example, no, there is no significant difference in the level of motivation of male and female. If the p-value that we see is lower than 0.05, we will reject the hypothesis, meaning that there is a significant difference. But if the value is higher than 0.05, we will accept the null hypothesis that really there is no significant difference. Okay? Wow, this is a very quiet class today. I am so not used to this. So now we will go to independent samples t-test. So for the independent samples t-test, so this determines whether there is a statistically significant difference between the means of 2 unrelated groups, as in unrelated groups. Later, ha. And then, so the null hypothesis is that there is no significant difference between group 1 and group 2 in terms of the dependent variable. Just like your gender, about just like what you will be testing in the sex, wherein there is no significant difference between this variable and the sex of the respondents. So that's independent samples t-test. No, there are 2 groups that you're going to test. So sample questions, we will be answering this now. So is there a significant difference between public and private senior high school graduate in terms of their college achievement test scores? And is there a significant difference between the level of preparedness of teachers and students in online classes? We will answer number 1. We go back to your Excel file, and we go to your Excel. So in here already is how you are going to do that. But it's very important that you remember that all these things came from the overall file. No, it's just separated so that it's easier to look at. No, it's actually better if it's really like this. You separate them. So what do you need? Type of senior high school, college achievement test results. So what do you do? What do you do is the first one is you have to separate the data into 2 columns representing the 2 groups. Yeah, there is already public and there's already private. So you just put the public here and then the private here, and then copy all the answers until the 89 for the public, and then the private you copy all. That's it. Just copy it. It's just there. Next, click data analysis, t-test 2 samples. I don't know what's wrong. Am I so in a hurry? Yeah. So let's go to data. Click your data. The data analysis should appear on here. Here. It should be here. And then we will click the t-test 2 sample assuming unequal or equal variances. We will use assuming unequal variances. No. Why do we use unequal variances? Because the numbers are not the same. So it's better if it's unequal. And then click OK. Now, variable range 1, so this will come out. Variable range 1, we have to input. Let's include the public, the name. Oops. Click until you get there. And then variable range 2, private. Click until here. And then since we included the titles, let's put labels. Are you following? And then click output range. Output range here. Where do you want to put it? I want to put it in here. Are you with me? You click wherever you want to put it. And then click OK. It comes out now. This is now your table. Now, not all these things are very important, no? What are the important things that we have to look for? Now, we go back to your Word file. Significant difference. Ito. Independent samples t-test. So for the independent samples t-test, we will need the mean of each group, the standard deviation, and the sample population per group. We will also be needing the t-value, the degrees of freedom value, and the p-value. Now, where are they? Let's go back here. What did we do? Okay. So in here, this is your mean for the private school and the public school. The variance, the square root, the standard deviation, this part, the standard deviation, you can use that or you can get that by getting the square root of the variance. Square root, ha? Square root function, SQRT. And then copy. Okay. Is it the same? Same value. 5.67, 5.56. Same value. Now, what else do you need? This one, the number of observations. This is the n, 18 and then 22. This is your, let's try. I'll try to color it. I work better with colors. Yeah. And then you also make use of the degrees of freedom. So that's DF. You will copy that. And then, what is it that we are going to look at? If you see here, there is one tail and then there's two tail. Remember that we are going to look into the two tail value, this one. What else do we need? That's the p value, the two tail value, the degree of freedom, and then the t is the 0.51, the t stats. Found it? Now, what does this mean? What do all these things mean? Mom, they're numbers. We don't care. They just went out. Surprise! It's there. Now, what do they mean? This is the standard general average of all the grades of the public schools and the private schools. Now, this one is the variance, the standard deviation. Again, the standard deviation is the dispersion of the data. The degrees of freedom, let's not work on that. And then the t-stats, they're just important. But the most important part here is this one, the t-tail value, the p value, which is 0.960. 0.960. Is it higher or lower than the p value? What's our p value again? What's our p-value, the most important value that you have to remember?
0.5.
0.05. 0.05. Is 0.960 higher or lower than 0.05?
Higher.
Yeah, that's higher. So meaning we have to accept the null hypothesis. That is why there is no significant difference because it's there. Now, please remember that you have to put all this data here. Keep this sample results and discussion. It would be very, very helpful for you because all of them should be written there. This is the APA format, APA standard format of writing your tables, writing your data. I don't know why it has to be there. Maybe it's for, no, it's for the people who really and fully understand statistics and research so that they get to picture the answers, they get to picture what is happening on your papers. But if you would ask me, I would only look into this part and the p-value. I don't care about the BF and the T or whatsoever. The most important part for me is the p-value in these parts. Okay? Understood this one? Is it fine if I give you an assignment on this? Can you work on yourselves alone? Yeah, of course. No, let's have another set of data later. No. Where are we? Now, let's go back. Have we answered this? The level of preparedness, we do not have a data for that, but that's how it should be done. So that's independent samples t-test. No, who among you will use independent samples t-test? Who will use? Ayan, very good. They know that they will use independent samples t-test. Yung male, female, and then colleges or departments or whatsoever. Now, we will go into the next one. Ayan. So remember that in order to run the t-test, you need the following things. So one independent categorical variable that has two groups. Independent and categorical variable that has two groups. Yung male or female, public or private, only two because you cannot do more than two. 3 is already for ANOVA. Okay? We will do ANOVA if it's more than 2. So just independent samples. These are supposed to be unrelated groups. As in unrelated groups, they do not have or they do not share the same characteristics, public, private, male, female, what else? HMTM, what else? Two groups only. Can you give me some examples of two groups only? The old and the young. Joke. Two groups. Section A, Section B. Yes, Jed?
Nursing and med tech.
Very good. No.
They only have 2 programs.
But you will not use this. you will not be using this. So they should be unrelated groups. No? And then one is a continuous or ratio or interval dependent variable. The dependent variable is the one that you are testing. Now, for the paired samples t-test, this time, this determines whether there is a statistically significant difference between the means of two variables from the same subjects. So it's the same people that you are using as your respondents, but they have two sets of data, pre-test and post-test, something like that. Is there a significant difference in the results of my pre-test and my post-test? Because you did something in the middle. That's quasi-experimental research. That is what's supposed to be done by Jerlyn, I think. Jerlyn, no, supposed to be. We will ask them to watch something and then we will see if there will be a difference between the reading comprehension in the beginning and after that. So if you plan to do an intervention, if you have, say for example, a program that you want to test and you want to check if it's effective, then you can make use of the paired samples t-test. There is a check at the beginning and then there is another assessment at the end. Yeah, so that's called paired samples t-test. So the sample null hypothesis, there is no significant difference in the dependent variable 1 before and after the conduct of the independent variable because there is an intervention in the middle. Yeah. Now, let's try to answer this. The first one, is there a significant difference between the MAC test results and the actual college achievement test results? Now we go back to your Excel file, pair sample C test. Again, it's written here, the directions of how you're going to use this. It's now separated, the MAC test results and the college achievement test. So it's easy because it's there already. So you have the same number, of course, because these are the same number of people. So 40 people took the mock test results. Took the mock test, sorry, and 40 people. What is so wrong with you? 40 people took the college achievement test. So these are the same people. Very important here is that you do not commit a mistake of putting my score to Jeanette's score. No, it should not be like that. No, be careful. My score should be compared to my next score. That's why it's called paired. That's a usual error. That's why it's important that if you have a quasi-experimental research, it's important that you get the names of your respondents so that you can encode them properly. Okay, nobody did the quasi-experimental. Now, how do we do that? So again, separate the data into two columns. Click data, data analysis. We go there. Data. Wait, I see your faces. Data analysis. We now go into t-test paired sample for two means. Two means because we're just working on the means of these things. So click OK. Variable range 1 again. I'll just click this first. Variable range 1. Oops. And then variable range 2. Here. Click in the labels because we encoded. Where do I want to put it? Maybe here. And then click OK. Ta-da! It's there. So these are now the answers. So same thing, no? If we need to get the standard deviation, what do we do to get the standard deviation again? How do we get the standard deviation?
Equals sign ko tapos ST del.
Nope. The standard deviation, if that's the case, it's just there. But if it's on the table already, we have to use the square root function. So SQRT, and then this one, and then there. So we'll have to color it now. Yellow. And then the means, we will get the means, of course. The number of observations, it's just there, it's just 40. And then the degrees of freedom, it's here. And then we go to your word. So what do we need? We need the t value. And then we need the p value. Where is that t value? T stats. Ma'am, why is it negative? Why is it negative? Why do you think is it negative? It's negative because the second value is higher than the first value. It's just actually it's just like that. It's just higher. That's why it's negative. So another important thing, we will get again detailed p-value. So these are all that you need. Then we go back to Word. And we now see that 0.07, higher or lower than 0.05?
Higher. No.
Higher. Therefore, do we accept the null hypothesis or do we reject the null hypothesis?
Accept po.
Accept, ma'am.
Yan. Very good. So we have to accept the null hypothesis, which is that there is no significant difference between the college achievement test results and the MAC test results. Again, no? So what do we get? We get the mean. That's a new mean. The mean is there, given already. You just have to copy that. You have to get the standard deviation by using the square root function. And then you have to get the degrees of freedom, the DF, yung p-stats, and of course, the most important value, the p-value. Still can follow? I'm enjoying your faces. Can you still follow? Do you need time to process? 5 seconds. So again, no, your paired samples t-test is used when you have the same respondents, but you have 2 sets of data from them, before and after. While the independent samples t-test is you have 2 sets of data, but these 2 sets of data are not from the same people. Okay? Kaya pa? Are you sure? It's just 10:14. I'll send you a sample worksheet later that we will work on now. Next. Now we'll go into ANOVA. For ANOVA, wait. So remember again, so in order to run the paired samples t-test, what you need are the following. Continuous interval ratio, dependent variable, that is our what we are testing. The paired measurements must be recorded in 2 separate variables. Again, you have 2 groups, but these you have 1 group, but this 1 group has 2 data sets that they have. And then, yeah, related samples or groups, the subjects in each sample or group are the same. This means that the subjects are also the same in the first group and second group. Section 1, all the people in section 1 and all the people in section 2, because you want to check if there is a significant difference in their scores. Let's think of it like that. We want to check the significant difference of their scores. Why am I not seeing this? Okay. Now, for ANOVA, can you still follow?
Yes.
Yeah. So for
No.
ANOVA,
Sorry. Yes.
for ANOVA, I mentioned a while ago, remember, that the t-test can only be done for 2 groups. Now, if we have more than 2 groups, now we will use ANOVA. You remember in the beginning, we made use of the different colleges. We have 7 colleges, CDAA, SED, FLAGE, and all those things. If we want to compare them all, we have to make use of ANOVA. With you, say for example, no, Cheska wants to compare yung Edu, Psych, what else? Edu, Psych, Social Work, and Bliss. If she wants to compare the means of these 4, she has to do ANOVA. But not everything can be done via ANOVA, ha? Because with you, it's fine. It's 101. It depends on the number of respondents. With Jeanette, will you do strands?
No po, ma'am.
She doesn't want ANOVA. Okay. She does not want to get into practice ANOVA, so she will not use the strand. Just the male-female, Jeanette. Jeanette, I think it's better if we do the strands. Because the data is there already. Yes, Donna concert. Okay, so ANOVA, no? So we will use this for more than 2 sets of data or respondents. So it tests the differences among the 3 or more means. So it checks whether there is a variation among the groups. And then the null hypothesis is that there is no significance in the dependent variable across, say for example, across colleges, across the strands. So there is no significant difference in the college achievement test results across colleges, or something like that. So sample question, let's try to answer this. Is there a significant difference in the college achievement test results scores across colleges? Yeah. Let's try to work on that. Let's go to your ANOVA, please. For the ANOVA, it's already here. Page, what's next? CDAA. Said. CHMP said. Unfair, there is no SINASH. Not there. So I just cannot see. Site, what's next to site? Am I right? CLAGE, CBAA, SED, CHMT, site, SINASH. Oh, saan SEDE? Site SEDE. SINASH. Now, what do you need to do? First things first, you have to separate the data into the groups. So since we've already classified them, it's easier. Just get them all. Just put them all together there. Just have to be careful that you might not, or that you might miss something. Be careful of missing something. Not someone, just something. Okay. Now, what? You know what? You're so serious, all of you. What is so wrong with you? Are you still fine? Okay, now let's go to data. Everybody, please follow. Data. Click data analysis and click ANOVA. Single factor. The first one, click OK. For this part, you do not need or you do not have a problem because you just have to click them all. Hey, but I cannot see. Wait, sorry. Yeah, just click them all until you highlight them all and then put labels. Output range. Oops, where do you want to put that? Maybe I can just put it here. And then click OK. It's there. But there are 2 types of tables that you will see. Now let's go to the Word file first. In your presentation of data, you will not need a lot of things. This is the standard table that we're going to use, the one-way ANOVA of college achievement test results between groups and within groups. Now, where are they on the Excel part? This one, between groups and within groups. Now, why do you need the first part? The first part is important because it shows you the averages and the variances of your data. But you will not see them here. It's not written there. It's only for reference purposes, that part. And also another thing is, in this Excel, the thing about Excel is that there is no post hoc analysis. Post hoc analysis will tell you who is higher, which one is significantly higher than the other one. It's not here. It's in the SPSS. Maybe we can work it out sometime. But with us, what's important is that we get the between groups and then the within groups. So we will just copy the SS. And it's there. The SS, the DF, it's just there. You have the DF, you have your SS, your MS. Do not forget that's Melanie Santos. I joke. It's just there. So your MS, your, now, this is very, very important. Your p-val, there's the F, it's there, no? That's the F value. And then there's the p value. Ma'am, why does it look like that? If you would read that, how do you read that? Actually, that is 4.007 times 10 raised to the 6th power. So meaning you have to go back. So meaning that is smaller than 0.05. To make life easy, no, to make life easier, we go to home, and then where is that? Wait, I want to see it once. You click this part. This one. You click the comma part there. You click the p-value, click the comma, and then there. 0.00. It's there, huh? 0.00. But when you write it in your word format, it's there. 0.0003, three values. But when you write it, it should be written as, in the interpretation part, it should be written as less than 0.001. 001. That's the absolute. It should always be there because you mean that there is really value to that. So this is it. This is how you do the interpretation of the one-way ANOVA. So meaning that there was a significant difference on the test results of the colleges. Diba? How do you know? Actually, if you would just look at here, if you just look at the table above, you see that really there's a significant difference. I'm sorry about this. I don't know what happened, but the said data is the lowest of all. Bad, no? And the highest is Clage. This is only for, I remember that this is only, this is only for research purposes and statistics purposes. It does not mean in that this is what happens in real life because I'm also from SED. Okay, no. So just upon looking at their scores, just upon looking at their mean averages, you already know, wait, I think there's a difference. Because take a look, the highest is 95 and the lowest is 78. How many steps would be the difference? 95 minus 78. Yay! Yay! Uy, 95 and 78, 18. Ay, 17, sorry. I now understand that you are really English majors. No? English majors? Okay, no. So just by mere looking at it, we can see that it seems like that there is a significant difference among all these colleges. And the highest would be Clage. So Clage is significantly different from them all. If we want really to test which one is higher and which one is the lowest of all, we have to do the Tukey analysis. But the post hoc analysis is in SPSS and it cannot be done in Excel. Okay, now I have a challenge and it's not on your data sheets. Please do the ANOVA of the, what's this one? College achievement. Please do the mock test results. ANOVA, please. Yes, you do that. You have to separate that because it's not here. It's not given. Do it yourselves. Add an additional tab. Go ahead. Do your works. And then I'll stop sharing. I'll just get something first while you're working. Done? Finished? Not yet. Thank you for your answers, everyone.
Yes. Ang yapang. Gusto niyo yun. Best in quantity.
Best in quantity, ah. Let's see. Wait. I'm just getting something.
Syempre, Jerlyn is panicking.
Is she?
Since earlier.
Is she panicking already? Darlene, are you still fine? How about How about the others? Are you finished? And then I'll send something. Later. Sorry, excited. I'll post